afternoon, everybody. Now we are going to discuss about the colligative properties of the solution. In the colligative properties of the solution, we have four properties: boiling point elevation, freezing point depression, osmotic pressure, and vapor pressure lowering. In this point, we are going to correct exercises, but now we are going to start by osmotic pressure. When we are saying about osmotic pressure, we are dealing with the solute in low concentration and the solute in high concentration separated. In the solution, two solutions are separated by semi-permeable membrane. For that semi-permeable membrane, it means that we want to know what is the pressure which can displace water from a given side to another side through semi-permeable membrane. This happened in biology in the property of the cell when water is entering or is getting out in the cell, and by the process called osmosis. But now we are going to see how proteins is exercising that kind of pressure, and we are going to see an example how we can calculate the molar mass of the protein when we know the osmotic pressure, and we can know the osmotic pressure when we know the molar mass of the protein or another biological molecule which is in the solution. Now we are going to continue to follow our explanation and exercises by taking into account to the text that we have here. First of all, let us read the question. Read the question about osmotic pressure. Here the title of the question is written colligative properties, osmotic pressure. The question is this: the osmotic pressure of a aqueous solution is the osmotic pressure of aqueous solution of a certain protein was measured in order to determine the molar mass of the protein. The solution contained 3.5 milligram of protein dissolved in sufficient water to form 5 milliliter of solution. The osmotic pressure of the solution at 25 Celsius degrees was found to be 1.54 or 1.54 torr. Calculate the molar mass of the protein. R is equal to 0.0821 atmosphere liter Kelvin minus 1 mole minus 1. This letter R represent the constant of the perfect gas. It is what we are going to use. But when we start the correction of the question, here we can correct the question by first of all providing what is given. First of all, we have to write given. In given, we have the osmotic pressure is not given for the first time, but we have the mass. Mass is equal 3.50 milligram. Another thing we have the temperature. Temperature is equal to 25 Celsius degrees, but because we have to calculate in Kelvin, it is equal to 25 plus 273, and we convert the temperature in the unit called Kelvin. Converting into Kelvin, we have 298 Kelvin. Because the temperature is in Kelvin, the R is expressed in 0.0821 atmosphere liter. Then the pressure will be in atmosphere in order to simplify the unit. More on Kelvin minus 1, mole minus 1. Those are what we have. But we cannot ignore that we have also the volume. The volume, we have also to deal with the volume, because the volume also is given. The given volume we have here, volume, it was 5 milliliter. Volume which is 5 milliliter, we have to convert into 5 milliliter, we convert into decimeter cube or liter. It is equal to 0.005 liter equal to 0.005 cubic decimeter. After finding the volume, another thing which we have to calculate is the pressure. Pressure, it is written that it is equal to 1.54 torr. 1 torr is equal to 760 millimeter of mercury. And 1 torr, 1 atmosphere is the unit we use, but 1 torr is equal to 1 millimeter of mercury. It means that because our constant is expressed in atmosphere, we have to express our pressure in atmosphere, means that it is equal to 1.54 over, it means that it is equal 1.54 torr over 700 torr. Then because this equivalence is equal to 1 atmosphere, it means that here we have the value equal to 0.026 atmosphere. It means that this is given by the calculator. If we use the calculator, you can divide 1.54 1.54 over 760, you find that it gives the number which is written there. Another thing, everything that we need as data, we have them, but we have to calculate again the formula. The formula, it is known formula in the ideal gas equation. We know that PV is equal to nRT. PV is equal to nRT. It means that this P is the pressure, V is the volume, T is the temperature in Kelvin. But this R is the constant of perfect gas. After finding this equation, but you have to write pi as the osmotic pressure is in RT. This is osmotic pressure. Here you know that what we have is the mass, is not the number of mole, but we know that number of mole is equal to mass over molar mass, and we know the mass, but we don't know the molar mass. It means that P times V is equal to mass over molar mass times RT. And here we have to replace what we know by what we don't know. We have to replace every unit or every in the formula what we know, and the unknown will be the molar mass which is asked to be calculated. Here the pressure we know, it is 0.002026 atmosphere times the volume, which is 0.005 liter, equal to the mass. The mass is 3.50 gram. Milligram. This is milligram, but for the mass we have to convert into gram. It will be 0.0034 gram, because we have to divide by 1000 to convert from milligram to gram. You find in the equation. It is 3.5. Then here what we have to do, it means that this is 10 power negative 3, and this is the mass over molar mass, which is not known, times R times T, and the R and the T are known. You find that molar mass will be equal to, by changing the expression, we can find that molar mass, first of all, molar mass will be extracted from the formula, and we find that by calculating the molar mass, we have to invent what we have. 1, here it is a gram. Molar mass, we have to say that molar mass is equal to 3.5 times 10 negative 3 grams times 0.0821 atmosphere liter, Kelvin minus 1, mole minus 1, times 298 Kelvin, which is the temperature, over what is with over 0.002026 atmosphere times 0.005 liter, and you find that liter expressed simplify with liter. I don't find here there is a Kelvin minus 1 mole minus there is no here there is no Kelvin. We find that this Kelvin simplify with Kelvin minus 1. The remaining will be mole and gram. The answer will be 8 by using the calculator. By calculating using a calculator, you will find that the molar mass will be equal to 8,474.576 gram mole minus 1. Mole minus 1. This is the molar mass by using osmotic pressure and the formula of ideal equation. What we have to add here is that in osmotic pressure we have a U-tube, and that U-tube there is semi-permeable membrane. Here there are solutes at high concentration, and this solute at high concentration, there is another at low concentration. It means that when here there is low concentration, and here there is high concentration. It means that in order to dilute, there is a transfer of the solvent, which is water, but there is equilibrium, because this is a point of phase equilibrium. This is a phase equilibrium, and thank you for watching this video. We will continue to deal with the other colligative properties for next opportunity. If you have the question, you have to subscribe and contact ask on 0788 4080 8582 or 0722 408581. Here you have also to see on Facebook and on WhatsApp. Udakubana epimark. You have to contact. Thank you and see you next. Don't forget to click on subscribe. Don't forget to click on subscribe. Click on the notification sign and click on like.